So the next we consider a two sample test of two populations of unequal variance. That's the more general case, right? Before we have equal variance, so now we don't make any assumption. The variance are different. So usually it means that, as you would expect, the critical value, right, would be much larger, right? More extreme. You need a more extreme sample, because if unequal variance, then you know less about, you make less assumption. It's more likely, more difficult to reject. So we focus on two-tail tests. You can easily see how things change when they're one tail, left or right hand side. So again, mu, they're the same mean. Two sample population same mean. The population have different mean. So the sample mean x1, x2, sample variance s1 square, s2 square, sample size n1, n2. The test statistic is x1 minus x2 not equal to mu minus mu2, okay, which is 0, right, in under the null. And this the standard deviation of this statistics, right, t statistics, is s1 square over n1, s2 square over n2, right, will be t of v. So this is not difficult to see because s1 s2 are independent. So the variance of x1 and x2 will be just sum of those, okay. And now this is a degree of freedom is not n1 n2 but is a v. So is v, what is v? It's a rather complicated object again. So this v is this is integer function, right? Just get the integer will be this is a denominator, right? The denominator of the statistics, right? And we square it, right? And then over something even more trickier is s1 square over n1 square over n1 minus 1, and same as 1 over n2 minus 1, and this is similar here. So it's rather complicated object, okay. And don't worry, all is easy to calculate, right? And also both software package will calculate this directly. Then the interval estimator, right, is x1 minus x2 plus minus t, right, and root of this guy. So this is followed directly from here. So there's nothing complicated, okay. So let's see why this is true. It's a very complicated problem, and so far there's no really good solution to this. And actually watch actually show this variance follow a t distribution with v is following this, okay. But look at this, all the sigmas 1 and 2, and in practice we use s, and here we use integer function, okay. So that is people would do in this way, okay. And the example we have is two populations do not have the same variance. Sample mean from one population, sample size 50, right, x1 is 40, s1 is 4, another one is sample size 40, 42, and 3. And the test statistic is easy, right? It's 40 minus 42, right, over 4 square over 50, right, and 3 square over 40, right, it's negative 2.7. And degree of freedom, you can see, is rather complicated calculation, but just plug in the formula. It's 87 point something, so take the 87 because it's integer function. So from t table, 87 because two tail, so it's 2.5%, right, it's 1.98. And this t, right, we have 2.7, right, 2.7 is extreme more than 1.9, so we reject x now, okay. The p-value will be looking at 87t bigger than this absolute value, right, the test statistics, right, which is 0.1, so it's less than 5%, okay. The confidence interval, right, again, is not something difficult to see, right, it's alpha, the same, apply, plugging the formula, right. So that's it.